In this video, I'm going to talk about arithmetic series. Arithmetic series is just adding up all of the terms in an arithmetic sequence together. And there are two different types of arithmetic series. One is for a finite sequence, so that's a finite number of terms, and the other is for an infinite sequence, a sequence that goes on and on forever, adding those up together. An example of a finite sequence that's arithmetic would be 3, 6, 9, 12, and I stop there. I just have 4 terms. An example of an infinite sequence would be 3, 6, 9, 12, ... going on and on forever. So the ... means it continues. And the lack of the ... here means this one stops. Okay. And this is a finite number of terms. It's only 4 terms. This is an infinite amount of terms. All right, a series is what I just said, the sum of the terms in a sequence. So the sum of the terms in a sequence. The partial sum would be the sum of just the first n terms of the sequence. So the sum of the first n terms of a series. So if I'm only adding up a certain amount, and we denote that partial sum by s sub n. So s sub n is just a partial sum of just n terms of the series. All right, now we're going to talk about finite series summation. So we're going to consider the following arithmetic sequence: 4, 6, 8, 10, 12, 14, 16, 18. That's the sequence. We want to find, for the first part here, we want to find s sub 3, which means we're finding the partial sum of the first 3 terms. So we're going to add first 3 terms. Right, and so s sub 3 we get by doing a sub 1 plus a sub 2 plus a sub 3. A sub 1 in this case, this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a 6, a 7, a 8. So a sub 1, 2, and 3 is 4, 6, 8. So I'm adding 4, 6, and 8, and that's going to give me 18. So my partial sum of the first 3 terms, s sub 3, is 18. For s sub 4, I'm adding the first 4 terms. So add first 4 terms. And so s sub 4 I get by doing a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. That's 4, 6, 8, 10. So I'm adding 4 plus 6 plus 8 plus 10. I could just add 18 plus 10, which gives me 28, since I already got s sub 3. For s sub 8, I'm adding the all of the terms together because I only have 8 terms in this sequence that was given to me. So it's s sub 8 is a sub 1. Well, actually, I might not have enough room for that. So I'm just going to write 4 plus 6 plus 8 plus 10 plus 12 plus 14, plus 16, plus 18. And when you add all of that up, and you can do it in your calculator, you're going to get 88. So the sum of all 8 terms is 88. The next thing I want to do here is compare these sums that were given to me. I want to add a1 plus a8, a2 plus a7, a3 plus a6, a4 plus a5, and I want to see what do those things have in common. So a sub 1 plus a sub 8 is equal to 4 plus 18, which I know is 22. So this is 22. And I'm going to just put that in a box. I have a sub 2 plus a sub 7 is 6 plus 16, which gives me 22. And I'm going to put that in a box. I have a sub 3 plus a sub 6 is equal to 8 plus 14, which gives me 22. And I'm going to put that in a box. And then I have a sub 4 plus a sub 5 is equal to 10 plus 12. Oh, I didn't mean to write it like that. Is equal to 10 plus 12, which is 22. And I'm going to put that in a box. Now, comparing all of these, I can very obviously see that all of these sums are the same. So each sum is the same. So each pair is the same, and that is 22. I want to explain how to find s sub 8 using the value of a sub 1 plus a sub 8. I could also say a sub 2 plus a sub 7 or a sub 3 plus a sub 6 because all of those things are the same. But I'm going to use the first one, so a sub 1 plus a sub 8. I know that this is 22. What could I do to 22 to get my final answer of 88? Well, I could take 22 and I could multiply by 4, and that would give me 88. And that makes sense because I just paired all of my terms up together. I paired all of the terms up together, and I have 4 pairs. That's my entire sequence added together. And really what I have here is 22 4 times. So I have 4 pairs, each with a sum of 22. Now I want to consider an arithmetic series that's bigger than just 8 terms. So I want to consider the 2 series 1 plus 2 plus 3 plus ... all the way to 100, and the series 2 plus 4 plus 6 plus ... all the way to 60. Focusing in on the first one there, I am pairing up, as you can see in the diagram, I'm pairing up the first number with the last number, the second number with the second to last number, the third number with the third to last number. And if I do that pairing, I want to know how many pairs I have. Well, I can always find how many pairs I have by taking the number of terms that I have, and in this case, that would be 100 since I'm counting by 1 each time, and I'm going from 1 to 100. I have 100 numbers, and divided by 2, that gives me 50 pairs. So I know that's 100 divided by 2, since I have 100 numbers there. I want to know what's the sum of each of these pairs if I pair them up the way that I just said. Well, I'm going to do 100 plus 1. 100 plus 1 gives me 101. Then I'll do 99 plus 2. That gives me 101. Then I'll do 98 plus 3. That will give me 101. And if I keep going, I'll see that each pair is going to equal 101. They're going to be the same. So each pair, the sum is 101. Well, I have 50 pairs that make up the entire series, each with a sum of 101. So that's 50 of 101, 50 101s. Every time I say of, I'm multiplying. So I multiply 50 times 101, and that gives me a total is 5,050. This is the sum of the entire series. Then going over to the next example, if I pair these up, so I pair up 2 with 60, and 4 with 58, and 6 with 56. If I pair them up like that, how many pairs do I have? Well, I'm counting by 2 each time here, and I'm going from 2 to 60. So I know I'll have a total of 30 numbers here. I have a total of 30 numbers. 30 numbers total, which means I have 15 pairs. So I have 15 pairs because I have 30 numbers total, or 30 terms total. And I want to know what's the sum of each pair of numbers if I pair them up the same way I did with the first one and the example before. First with the last, second with the second to last, third with the third to last. Well, I have 60 plus 2 gives me 62. I have 58 plus 4 gives me 62. And 56 plus 6 gives me 62. So the sum each time is 62. I have 15 pairs of 62. 15 times 62, that's what I just said. And that gives me 930. So the sum of this series, very quickly I can find, is 930. So a general rule, If I have a series, I'm adding a sub 1 plus a sub 2 plus a sub 3 all the way to a sub n. I set it up a diagram for us here. I want to write an expression for the number of pairs of terms in in this series that I have listed here. Well, I know I have n terms total. Which means that to find the number of pairs that I have, I'm going to divide that number by 2. I'm going to pair everything up by dividing by 2. So I have n over 2 pairs. That's how many pairs I have for as a general statement. If I'm going from a sub 1 to a sub n. I want to write a formula for s sub n, the partial sum of the arithmetic series. So a general partial sum formula. I have s sub n is equal to, well, I have a look at my last examples. I had the number of pairs times the sum of each pair. This was the number of pairs times the sum of each pair. So the pattern that I see, and that's the same thing I saw with the first series I looked at too. What I'm doing is I'm taking the number of pairs and I'm multiplying by the sum of each pair, and I can find that sum easily by looking at the first term and the last term. So the sum of the first term and the last term. I could also look at the second term and the second to last term, but the easiest one to look at is the first term and the last term. So I'm multiplying the number of pairs times the sum of the first term and the last term, and I can denote this formula by s sub n is equal to, I'm going to say n over 2 times a sub 1 plus a sub n. This is the first term, this is the last term, this is the number of pairs. And I'm just going to color code this after it lets me erase. So this is the number of pairs, this is the first and last term added together. And this is the formula I'm going to use to find the partial sum of a series. Now we're going to go over what's summation notation. Summation notation is just another way of writing the question. It's another way of telling you to do the sum of something. So the sum symbol, the symbol that we use for sum, and if you ever use Excel, you see the sum in Excel. You probably don't use Excel right now in your life, but you definitely will in the future. So everybody uses it. But this is the sum symbol. So it means the sum of. So it says the sum of, and first thing you're going to start with is you're going to say what numbers do you want to sum together. The smallest number, or the number you're starting with, smallest n value goes on the bottom. And you're usually starting with the first term in the sequence. So it's going to be n is equal to 1. And then you're going to go to the greatest n value. Greatest n value is going to be on the top. And what this says is I'm the sum of the first term to the nth term. That's what that says. And then next to it, I'm going to put the explicit formula. That way I can find what the sums, or what each term is, So the explicit formula for the sequence. Okay, and that's another way of writing, do the sum of this. And here's the explicit formula for you to find the terms that you're adding together. So let's do an example of converting this into summation notation. I put my weird E looking shape on the top. I know I'm going from a sub 1 because it didn't specify elsewise, so I always just assume that's the first term, to a sub 50. I'm adding 50 terms together, 8 plus 16 plus 24 for 50 terms. So on the top, I'm going to put 50. On the bottom, I'm going to put n is equal to 1 because I'm starting with 1 and I'm going to 50. I want to indicate what am I actually talking about. I'm talking about position here. So I need to include n is equal to on the bottom. Since I already included that on the bottom, I don't need to include it on the top, so I don't need to write n is equal to 50. But I'm saying the sum of position 1 to 50 And here's the explicit formula next to it. So to find the explicit formula, I know first thing I need, most important thing is I need to know the common difference. From 8 to 16, 16 to 24, I know I'm adding 8 each time. So D is equal to 8. The next thing I need for my explicit formula is my first term, but I like to use the preceding term to the first term. So I like to use a sub 0, or the term before the first term. So a sub 1 is equal to 8. I know since I would be adding 8 to get to the next term, to go backwards, I would actually be subtracting 8, and that's going to tell me a sub 0, or the term before the first term, is equal to 0. So if I want to go backwards, I would subtract 8, and that would give me my term before 8 is 0. So I'm going to put 0 plus, I know I have my common difference, times n, and that's the explicit formula. Another way I could write this, a simpler way, is I could write n is equal to 1 to 50, the sum of 8n. I don't need that 0. So this would be, this thing tells me, do the sum of the first 50 terms. Here's the explicit formula, so you can find each term that you're adding together. All right, let's do the next example. So I have 6 plus 9 plus 12 plus 15 for 35 terms. So I'm going from a sub 1 to a sub 35, even though a sub 35 is not listed there. I know first thing I need is, what am I starting with? I'm starting with position 1, so n is equal to 1. I'm going to position 35. And I know the explicit formula. First thing I need is what my common difference is. I know from 6 to 9, 9 to 12, 12 to 15, I'm adding 3 each time. So D is equal to 3. I take my first term, which is 6, to find my term before that. And you can write your formula if you want with the first term. But I want to write it with the preceding term. So I'm going to subtract 3 to get a sub 0, which is equal to 3. So a sub 0 is equal to 3. That's the term before the first one. I'm going to put that here. I'm going to add the common difference, which is 3 times n. That's my explicit formula. This thing says I want you to add the first term through the 35th term. Here's the explicit formula so you can find what each term is. All right, so let's do an example. I want the sum of the first, from the first term to the fourth term. Here's the explicit formula. Whoops, it's not letting me. Here's the explicit formula so I can find what each term is that I want to add together. First thing I'm going to start with when I'm doing a series, I need to know the number of terms that I have. The numbers of terms that I have, I'm going from 1 to 4. From the first term to the fourth term, I'm adding a total of 4 terms together. The next thing I want to know is the sum of the first and the last. So I want to find what's the first term, what's the last term, because I'm going to use those sums multiplied by the amount of pairs that I have to find my final sum. So I'm going to start with the first term. And to find the first term, what I'm going to do with what was given to me, I'm going to use my explicit formula to find it. This is my explicit formula. And that tells me, if I know the position of the term, I can find what the term actually is. I know for the first term, the position is 1. So n is equal to 1. I'm going to plug in, and I'm going to get negative 2 times 1 plus 3, which is equal to 1. So I know a sub 1 is equal to 1. My first term is 1, based on that explicit formula. Then I want to find my last term. So my last term in this case is the fourth term. So the position is 4, n is equal to 4. I'm plugging that in. I have negative 2 times 4 plus 3, which gives me negative 8 plus 3, which is negative 5. So I know that a sub n is equal to my last term is negative 5. And I could say that's a sub 4 instead if I wanted to. There are 2 ways that I could evaluate this series. So I'm going to use the information I have now to evaluate what the series is, the sum of it. So I want to find s sub n, or in this case, s sub 4. I could just find the 4 terms and add them together because there's only 4 terms here. So I know the first term is 1. I know the explicit formula tells me the common difference is negative 2. So to find the next term, I would subtract 2 or add negative 2, and that would be negative 1. And then the next term would be negative 3. And then the next term would be negative 5. And then I would add those terms together. So 1 plus negative 3, 1 plus -1 plus -3 plus -5, which gives me -8. I could do that because I only have 4 terms there. But most of the time, you're going to have a lot of terms like 67, which will be the next example that we use. So another way that I can do this, and the way that I'm going to do it for the most part, is I'm going to use that formula that we derived. So using the formula for S sub n, I know S sub n is equal to, in general, n over 2, that finds the number of pairs that I have, times the sum of the first term and the last term. So I'm gonna plug in all of this information. I have 4 terms here that I'm summing together. So n is 4. I'm dividing by 2. That's telling me I have 2 total pairs. And the sum of each pair is 1 plus -5. The first term was 1. The last term was -5. And when I do this, I have 2 times -4. Each pair is -4. I get a total of -8, which is the same answer. All right, let's try the next example. First thing I want to do is find the number of terms in the series. So I'm going from the first term to the 67th term. That's a total of 67 terms that I'm adding together. So 67 terms. I want to find the first and last terms of the series because I want to know the sum of them, because that's going to be the sum of all of the pairs if I pair the numbers first and last, second and second to last, third and third to last. If I pair them, they're all going to be the same thing. So I'm going to focus in on the first term and the last term. So the first term, I know the position is 1, so n is equal to 1. I'm plugging in n is equal to 1 into my explicit formula, which was given to me. It's my explicit formula, and that formula I use to find any term in my sequence. I plug in the position. N is always the position. So the position is 1, so n is equal to 1. I have 5 times 1 plus 9, and that's equal to 14. So I know a sub 1 is 14. And that's my first term. And then to find my last term, in this case, my last term is the 67th term. So the last term is in the 67th position. N is equal to 67. I plug in 67, so 5 times 67 plus 9. You can do that in your calculator if you need to. It's 344. So I know a sub n, or my last term, is 344. I could also say a sub 67. To evaluate the series, I'm going to use the formula S sub n is equal to n over 2 times a sub 1 plus a sub n. I know I'm doing the sum of the first 67 numbers, so I'm doing 67 divided by 2 to find the total number of pairs that I have. And then I am going to, I know the sum of those pairs is the first term plus the last term, so 14 plus 344. And the total that I get there is, when I do that multiplication, I have 11,993 is my sum of this series.